be taking both the sessions. Okay, sir. Please, you may start.
Yeah, sir. Hi, everyone. So my name is Sai Kumar Danla. So today we are here to have a very good session. So yeah, I think, sir.
Yes, sir.
Shall
Please
we
join,
shall we
sir.
start? Yeah, shall we start? Means I think everyone is joined, right? Almost. Hello.
Yes, sir. Yes, sir.
Yeah, sure.
Yeah.
Okay. Yeah.
So do
Hello,
so
everyone.
so so Raju sir just called. So do you want to wait for some time because we have I didn't get that last part what you were saying.
No. I'm just asking, is still any participant needs to join, or shall I start the session?
Actually, time is up. Now we are having like 76 participants. So that's
Yeah,
a
I
little
think.
low, actually.
Okay. Means
That's a
what is the
little low.
total count?
Total 270 participants has been registered. Okay, but on an average, we are having for the last 3 days like 200 around.
Okay. Yeah, that's what I
200
just
around
asked.
we are getting.
Yeah, that's what I just want to make sure again. Like whenever I
Yeah,
start, I just
yeah.
wait
People
for
are
it. Maybe.
joining. People are joining. We have clearly mentioned in the WhatsApp group as well
hmm
as in the mail as also.
Sure. So I
We have
think
81 participants, so it's up to you
yeah, sure,
because
sir. I
everybody
think
knows the time.
yeah. And yeah, I just started sharing my screen. I hope everyone can view my screen,
Yeah,
right?
yeah, yeah. I can see your screen, sir.
Yeah. So yes. Yeah. Good afternoon, everyone. So my name is Sai Kumar Danda, and I'm a research scientist in Amazon. So previously worked as a scientist in DRDO. So today I'm going to give you a complete understanding about convolution neural networks, along with one hands-on coding session, like complete hands-on coding session, how a convolution neural network is going to solve a real-time problem. So that is today's in our session we are going to discuss that. So before going to start my session, I just want to give you some kind of idea what is the what kind of project we are going to discuss. So see, normally as a human beings, like neural networks and everything works similarly, like how a human brain works, right? So most this is a very standard point. Most of the people or most of the researchers are mentioned. So, but how it is really means,
Sir,
that is my point.
uh, hello. So sorry to intervene. Your
Mhm.
screen.
Yeah. Hello.
Yes, please go
Uh,
ahead.
yeah, sir. I think my screen is visible, right? I mean,
Yes,
someone
sir,
asking.
Sir,
visible,
your
but the
screen is
Sir,
someone
not
is
visible.
someone has
No, you
concern.
didn't share your screen, I think.
sir, actually your screen is not visible. Actually,
Oh,
No,
I
screen
just
actually he shared. So we are seeing only the MS Teams only. So he will share. He will start with his PPT or something.
okay. Yeah.
Sir, your
I
voice is audible, but up to now you didn't share your presentation, no?
No, no,
Yeah,
no.
I'm
He
just
didn't.
we are in that team link only. Not so I think now are you able to view
Yes,
PPTs?
now we are able to see your screen.
Yeah. Before starting session, I just want to give you idea what we are discussing instead of directly
Oh,
start a session. So I just want to how means give you some kind of introduction idea about what we are going to discuss in a session, in an entire session, along with hands-on, along with the theoretical and concepts. Okay, so that is a primary objective. And see, every time I used to divide a session into three parts majorly. In first part, I used to discuss more about what is the problem statement and what is the business on it. If see in industries, most of the people are seeing a problem with respect to business, or in research we are seeing a problem to how it is useful, our solution, how we improve, or how much improvisation we get in our solution. So basically this is the very high level talk in part one. So in part one we used to get idea about what, and a high level idea like a normal one who does not have any idea about deep learning also they can understanding means what we are going to do. That is a main concept in part one. It's like I make in a three parts. Entire session I make it as a three part. So in what my point is, see, for example, I think my screen is visible to everyone. So let us take an example. So this is one competition. So like this is Kaggle. So Kaggle is normally uh, hosting the competitions. So here you can see these competitions. Okay, so in this competition, so here this is a one competition. So where this competition comes under our scope actually. So I will tell you how it is. So in this competition they are trying to identify the plant species of Americas from herbivorous specimens. So this is the concept. So they are having different plant species. Out of that plant species, if you give the input as an image, then we need to identify the plant species. Correct. So this is the kind of idea. So like this is the kind of problem. Like even for example, if you have a if you see the plant diseases, for example, cotton seeds means cotton, you know, right? Cotton in cotton, cotton agriculture means in agriculture cotton, like that cotton's plants having different means cotton plant leaves having different diseases. But in high level, if you give means as a if any expert farmer, if you see in a real time example, if any expert farmer is there, so that expert farmer is going to see the leaves, and based on the his earlier experience or based on his previous experience, he identifies the what is maybe what maybe the disease it can be, like that, right? So based on his knowledge he can able to say, hey, so the leaves are seems to be like this, so probably this is the going to be the disease, something like that. So here deep learning or machine learning is something giving knowledge, like giving knowledge to the mission, right? Knowledge in how the knowledge or anything is something like we need to feed the data to the machine, something like hey, if we find the leaves diseases something like this, like leaves something like this, then this is the label or this is the kind of diseases. If we feed this information to the machine, then in future if any plants having the similar kind of or very close to that disease, then our model will predict, so this kind of leaps comes under this category. Correct. So it is something we are first initially we need to train the machine or train the model with previous experience. Previous experience is nothing but where we need data as well as the true labels. So these kind of problems are categorized as a supervised learning, and these kind of problems are these kind of with respect to data we are using image, right? So this kind of problem comes under computer vision problem. Okay, so yeah, so for that note, I'm going to explain. This is our coding session. I make some means I made a complete hands-on code. So I will come to this code by the end of the means after our theoretical session. So here, what my objective is, for example, here you can see. So yeah, I will show you what what we are going to do by the end of this session, what we are going to learn especially, I can say. Yeah, so here we have a data. So this is basically a data set. Means my main concern in this session is to understand the convolution neural network, and what are the means what is the family or what is the history of neural network family, like transfer learning and different things are there. We can discuss on the slides. So as of now, just not focus on that point, just focus on we are going to solve one problem. So let's think about that, let's understanding about the problem. So here we in this problem, our problem is something. I'm going to give you some image. You need to say what that images represents. Okay, so this is the data set we have publicly available data set, and it is a very good data set for the beginners or intermediate persons who is learning computer vision problems. So that's what I picked this data set, and this data set is very simple and easy to learn. So that is for that reason only I picked this data set for all the audience to understanding entire session, and they need to learn at least from beginning to intermediate level. Okay, yeah. So here in this data set, what we have three kind of data. So means three kind of folders. In each folder you can see. So this is with respect to training folder. If you see the training folder, we have again some subfolders. Here you can see this is building. So one building folder is there. Here you can see the buildings. Yeah, different buildings are there. So yeah, there are multiple buildings are there. So what my so we have one more class also there, like forest. So yeah, here you can see different forests, different images of forest. So by the end of the session, we are going to develop the algorithm, or we are going to make a solution. That solution is able to recognize the information, or able to classify the image. If you give the image as an input to the model, that model will tell what is the class. For example, if you give the input, this image as an input to the model, by the end of the solution, then the model will tell this image is a forest. So it is like an image classification. So in means today we are going to, means I will start step by step manner. So today we will start from beginning to intermediate level. Tomorrow, in our tomorrow session, I'm just making everything in a connection ways, like connecting ways. So tomorrow session we will discuss from intermediate level to advanced level. But today's session is very important. So I want everyone to listen, and means everyone to be in a same page. And if anyone have any questions, please let me know. Every time I used to stop and I used to ask the questions if anyone have or not. So something like that. We are taking some data set, and our purpose of, means our problem statement is we need to classify the image. So the problem statement is very clear. We have a 6 categories. Under the 6 categories, we need to classify the image. So that is a problem statement. And what is the metrics we are using? We are using accuracy. Okay, for our problem statement or our solution, we are using accuracy as a metrics. Okay, and this is the data set. In this data set, we have a three files. One file is with respect to training, and one file is with respect to test or validation, and one file is with respect to prediction. Prediction is nothing but completely in feature. So feature in a sense which is not at all idea about the model. So model will predictly directly based on the values. Like here you can see there is no label here. So directly we will give this as an input, and we will see what is the class, or what is the class we are going to get. So this is the idea, and this is the project we are going to discuss by the end of, we are going to solve by the end of the session. And I hope everyone is clear. So if anyone have any doubt regarding this explanation, whatever we discuss, please let me know through the chat. I prefer the chat mainly because it will uh, reduce the unnecessary uh, collapse between multiple people. Okay, yeah.
Sir, actually, in this MS Teams, those who are, most of them has joined as guests, so they are not having the chat option. So what we are suggesting to all the
Mhm.
participants, so if you have any questions, so please put it on in the WhatsApp group. So I have a team waiting, so they will take it up from there and let you know. Is that all right?
Yeah, that is right. But I request the participants, if the participants are very polite, I mean very cooperative, so they can unmute themselves and they
Yeah,
can
yeah,
ask the
yeah.
question.
That
If
option is available, sir. That
yeah,
option
yeah.
is also.
But I don't, means I want in a systematic manner, instead of if two persons are unmute at a time, so there is a collision will comes, na? So that's
Right, right,
yeah.
right.
I
So,
don't.
so
So we
please,
need to
participants.
make sure it's synchronized way. So then
Yeah, yeah.
that yeah. So yeah, that is a point. So I want everyone to understanding this statement. What is the problem statement we have, and what is the data we have, and what is the goal we have, and what is the evaluation metrics we have for evaluation our model or our solution, to evaluate our solution. So these 4 points everyone is clear. I'm expecting, means I want to know everyone is clear, right? Yeah,
Clear, sir. And we
yeah,
can raise the hand, so avoid that
yeah.
confusion to at a time have a multiple people to speaking.
So you can say them right, hey, okay, so and so person. We can raise our hand if we have a
Yeah,
question. So once you
yeah,
give confirmation, we'll unmute ourselves. Otherwise, we'll be in mute.
yeah. I
Yes,
think
sir.
that is a
That's a
very
very
good
good
idea.
idea. Thank you, Mahinder
Yeah.
ji. So,
Yeah.
sir, you can see the raising hand option.
Yeah,
Yes, sir.
sir, sir, Chatterjee, sir, whenever any person
Yes, sir.
raise the hand, please allow the person
I'll let you
and
know.
yeah, and ask the
Okay.
questions. And I
Okay.
request
Sure, sure.
everyone. I mean, I'm expecting everyone is clear with our 4 points. First point is a problem statement. So our problem statement is we need to build a solution. That solution is able to classify the image based on the image that is able to classify the 6 classes. Basically, this dataset having 6 classes, we can have a n number of classes based on our dataset. But this is the data provided by the Intel basically. So if you want something, we need to make it. Means we need to develop our own basically. If we want to develop any research or any kind of own solution, we need to gather the data also based on our requirement. But this data is publicly available and it is available in Kaggle and multiple resources, multiple places it is available. So I'm just taking this data to understand end-to-end solution as well as the neural network concepts. So that is the main motto for me. Means motto in this session to understanding every participant to how image classification works. Okay, so the first statement is like we have the first point with respect to problem statement. I hope everyone is clear. And the second point, we have a data set, and in our data set we have a three different data. One is with respect to training, and one is with respect to validation, and one is with respect to prediction. This prediction is completely in feature. We can say in feature. It is not at all visible to the model or learning. So we will. I will show you how it is. Okay. So this is with respect to data. So that is my second point. And third point is we are using the for so whenever we build a model or we are using we can build a model using any kind of neural network, whether it is convolution neural network or any kind of pre-trained learning like VGG or there are so many things are there with respect to algorithm, but we need to measure the algorithm, measure the performance of algorithm. So that's why we are taking the evaluation metrics called accuracy. Accuracy is something out of how many classes. Like for example, basically we have a for example if you have a 100 images, out of 100 images, and we know that true label is something 80 images are 80 images are correctly classified and 20 images are incorrectly classified, then overall accuracy is 80%. So that is a very high level information about the accuracy. So this is the evaluation metrics we are using for our solution. So this is with respect to third point. Okay, so these are the three major points I want to everyone is clear. So then we will let we will go with our slides and technical means theoretical understanding, and later we will come to our hands-on session. Okay, so this is the main agenda so in our session. So yeah, I hope everyone is clear. Like if anyone I'm just waiting for 1 minute to answer if anyone have a question related with this explanation, like these 3 points and till now whatever we discuss. I'm just wait for 1 minute. If anyone have a question, raise your hand and ask the question if you have. Otherwise I will move to the next part. So there we are going to get more idea about what kind of neural networks we are going to use to solve this problem, or what kind of neural network we have. I'll just wait for 1 minute if anyone have any question. Otherwise, I will continue. Yeah. Yes. Please go ahead.
Yeah, Mahinder ji,
So,
please ask the
yeah.
question.
Yeah.
So there is two questions. So one is related to first the three topic what you have covered, right? The algorithm. The third point we are building on network, right? So in this
Yes.
problem, what we are
Statement.
going to use it like a for statement. This one like a. So my problem statement classifying the image, right? And the data
Yes.
set is like a running all those three folders where we have seen.
Yes.
Now,
Yes.
what tool or like a what application we are going to use, like algorithm we are going to use to image classification?
Yeah, that is a good question. So I think you can get the answer on next slide, means in next part.
Okay.
So yeah.
Okay, so that's one question. And the other question, someone in the group was asking about, is this like a for meeting same for the Python beginners? So someone was like
No,
asking
no.
that question.
Can you
So
please?
Actually, let me answer this because I am from the coordinating group. Python beginning course was a different session. So we are like giving you a idea that is not in the this part. Okay, that's an extra thing. That's optional. Our main concern is that this AIML course. Okay, sir.
okay,
Sir,
so
Okay,
that
so
here
people.
There
I
is
just,
no Python course now.
yeah,
We
I
will
will add
follow
a
our
note on
normal
this.
schedule.
Yeah. Sorry for interrupt. So I will add a note on it. So it's basically we required, means whatever we are learning now, it is already need a requirement of Python. Means at least have a
Okay,
high level idea about a Python. So then only you can have you can clearly understand. Means that Python things are comes here. So here you can see
ah,
import NumPy
okay,
OS and everything
okay,
comes here.
NumPy and all.
Yeah,
Correct,
yeah,
correct.
yeah.
Okay,
Python things comes here, but I will this will cover in a third part, means in a hands-on session. But I will come to one by
okay,
one. In yeah,
okay. Yep, got it. Thank you.
Sir,
yeah,
Prabhakaran, can we create our own?
yeah. I'll means sir, can you please talk loudly? I'm not able
One
to
minute,
get your
one minute,
voice.
1 minute. Sir, sir, is it possible to create our own data sets in using Kaggle?
Yeah, means Kaggle is just a place to store the, means place to publish the data set, sir. Like if you want to create your own data set, just do something like this, like uh, means create take see, for example, if I want to make my own data set with respect to image classification on
Okay,
cotton seeds, like cotton leaf diseases are there na, every time in every season we can see the cotton and cotton leaves, and there is a multiple diseases also there. So if you want to
mhm,
do the research on that part, if you want to do a specific research on that part, you need to collect your own data set. So at the time what you need to do is for each disease, for example, one disease is there ABC. So for
okay.
that disease you need to collect some 1,000 samples. 1,000 samples means 1,000 images at least.
Yeah, I got it. I got it. Yeah.
Yeah, it's something like that. If you want to develop your own research, or if you want to develop your own things, you need to make the data also that is with respect to your research or your business statement.
Yeah, actually, I'm currently having some thousands of data with me
Yeah, yeah,
with
sure.
image. Okay, so that
Yeah.
images and all, can I put it over here and can I create a data set for my own?
Yeah, sure, sure. Definitely we can do that. But one thing, whatever the image you have, do you have the true label also with respect to image? Means we need at least image with respect to their label also we required in training data.
The label, anyways, the label also I'm going to give on my own only actually.
Yeah, yeah, sure,
So,
sure. In that case,
so
basically here, yeah, I think for that question you can see here. Here, this is the training in this Intel image classification dataset. There are three files are there. If you are able
mhm,
to see, like this is with respect
yeah,
to training data. So training data is something we need to train the algorithm, train our algorithm with respect with using this training data. Okay,
okay,
so whatever we are training, so at the same time we are going to use the validation data set. That is called as, basically here it is mentioned as a test, but normally it is called as validation. So this validation data set, whenever we are building a model or algorithm, so at the same time we are giving validation data set. By using validation data set, we can our model improve the algorithm. Means the learning will takes place. Okay, we are directly driving the patterns from training data set and test on the test validation data set. If we find any error, the model learn itself and try to see in a better way. So once these two things are done, then model is ready for you. Then you can do the prediction on the future images. See here, there is no label. Here directly you can give this image to the model once your training and everything is done. then you can directly give this image. At the time, you no need to think about what is the label or what is the class of that image and all. You just simply
Okay.
give that image to the model. Model will tell you, hey, this image is classified as a this class or something like that. Whatever you have, whatever
So
you
it is
train.
like it is
Yeah,
like during the training and
training time.
testing time,
Yeah.
whatever the images I utilized, I used
uh,
the same image. I need to give it in the prediction part also, or it can be of any other images.
yeah, if you give same image or near to that, or uh, probably like it is like a clusters. If you see the
Okay.
clusters, basically if it is inside
Okay.
the cluster, see, I will tell you, like
And my next thing is that cluster also actually. So anyways, you have told.
uh, yeah, see, for example, I have a three classes, for example. So
Okay.
what happens, the machine learning, like something, it will able to, means it try to find the clusters. So it three clusters. Whenever any
Yes.
new image comes, so first it will place somewhere around here, or somewhere here, or somewhere here. Okay.
Mm-hmm.
So if it is near to this class, then it is classified as this one. If it near to this, then classify as this. So if it is near to this, then classify as this. So if somewhere
Okay.
around here, but
Mm-hmm.
it is very hard to model will take which is this one or this one, this one. So then those kind of images are called as false predictions. But we can see in machine learning we are able to find the accuracy of 85% and 90%, right? That remaining percents are the false images, means false predictions. So something
Mm-hmm.
very
Actually,
rare situations. Yeah,
Actually, my data sets also looks like the round shape which I have put like this. It is
yeah,
irregular
yeah,
shape actually. It
yeah,
is
yeah,
not in a regular shape, and it will be like cluster one on the above also. It will be there, and
yeah, yeah. See,
there also
basically
I wanted
whatever,
to predict this.
yeah, basically whatever this machine learning is trying to do, whatever the data you have, it trying to figure out the patterns or behavior. So
Yeah.
once the pattern is matched, see, if in future data set, whenever you do the prediction on a future image, so if the pattern, whatever the pattern is present on that image, so then it is classified as that pattern. But
Mhm.
we are having 85% accuracy, not 100%. So there is a chances to uh, predict 15 percentage of chances to predict image as a false prediction. So basically
Then
that is
how
the,
can I overcome this, sir?
so there is no way, sir, like there is no algorithm is going to be 100%. We need to make sure at least 90% is enough to enough actually.
Mm-hmm. Mm-hmm.
So in
Mm.
industry also there is no model or no algorithm for 100%. So max to maximum we are getting 90
Uh-huh.
to 95%
Okay.
maximum.
Okay.
Yeah, this is
Okay.
enough actually. That's 5% is very minimal, so it is okay to it is not impacting anything on a business as well as results.
Mhm.
Yeah. Okay, I think
Actually,
that is required.
actually, I'm having one model, so
Yeah, yeah,
there I
sure, sure,
thought of
sure,
use this, but again, same thing. Like I'm using this Arcascade machine language, sorry,
sure,
machine
sure,
learning algorithm. So there also I'm getting the problem. Like this,
sure, sure.
when the clustering is coming there, I'm getting the problem.
Yeah,
So I
sure,
thought
sir.
of testing.
Yeah, I think so. If you need any extra or any points, so means you are asking very specific, right? I think the remaining
Yeah,
audience
very
not
specific.
required. Yeah, yeah, remaining audience not required this. So I will share my email ID. So you
Okay,
just send a mail with all your points. Then we will discuss separately. But
definitely. Okay.
we need to give a time to everyone. So yeah, we will. I need
Thank
to
you. Thank you.
continue
Thank
with other. Yes.
you. Okay, fine. Thank you. Thank you.
Yeah. Thank you. Yeah. Okay,
Um,
so
sir, yes, sir.
any other?
Sir, one more.
Okay, Mr.
See that.
Arulmani K, you have raised
Yeah,
your hand, so go ahead, please ask.
and please take your question in a limited way. So probably you can get answers in next slides. If it
Sir,
any,
I got an answer for.
yeah, yeah, please
Sir, I
go ahead.
got an answer because my question is, my own data is used or not.
Yeah,
I
yeah,
all
we can use.
you already told that question, sir.
Yeah, sure. Thank you.
Thank
Yeah,
you, sir.
So we have
I
two
think, sir,
more people
okay.
who've raised their hands. Mr. Viru, you can ask your question.
O- Okay, so if anyone has any question, please ask. So I
Sir,
think
myself
it's
Nanaj is lover.
disrupting the session. We should.
Hello, am I audible?
Yeah,
Yes,
yeah.
yes, yes.
Hello.
Please go ahead.
Sir, myself Nanaj is lover. Sir, I
Okay.
have a one doubt. Actually,
Okay.
presently I'm working on hydrogen storage material. Now,
Okay.
hydrogen storage materials, plenty of materials is there. So I
Okay.
have to shortlist those which material is best, which material is giving good property, how I have to choose and how I have to limit the data.
Means what is the data? Means what kind of data you have? Whether the data is in images or in whether the data is in
Sir,
numbers.
all are
What
property related. Suppose physical properties and optical properties related and microstructure related.
which means you are having some kind of tabular data where you are having some means features or attributes
Yes, yes,
yeah, and based on the attribute value you are having some kind of true value in a
yes,
sense
yes, yes.
yeah.
Yeah,
So
this data I collected from that literature and I
mhm.
have all datas. So using this data, I have to build that new material. It will be possible to build new material.
Yeah, actually, yeah, I'm not very sure what you are trying to ask. Means based on your statement and based on the whatever you are provided information. So here you are asking something like this. So I'm just drawing here. You can see. So here this is your table, for example. So this is your one feature or one column, and this
Yes,
is
sir.
your second column, and this is
Yes,
your
sir.
somewhere three column, and this
Yes,
is
sir.
your final required output or required
Yes.
targeted value.
Mm.
So what you can do, first you need to collect the again same thing. So you need to collect the true labels,
Mm.
which means see, for example, one record. So for example, the record is something like this. So in the record you have some with respect to column value, some x value is there, some y value is there with respect to column 2, something is there in column 3, something is there. So based on this value, this is the your true variable value, means this value you already know, this is already known for us. Okay, so that value
Yes, sir.
we are having here. So something like this, so something we need to make, so something we need to have. So so this is the training data basically. So
Mm.
you need to first make the training data something like this. Now whenever you are whenever you are make means if you have the training data, then you can apply your training data, means you can apply any means one of the ml algorithm. Means
Mm.
I think this in this session I'm going to not cover that thing. So you
Mhm.
can try to apply any one of the ml algorithm. So
Mhm.
and your values, means your output values something like integer values, right? Like
Yes,
rational
yes,
values,
yes.
like
Mm.
something like minus infinity to means plus infinity, something like that,
Yes.
right?
Mm. Mm.
Like 51, 52, 53,
Yes, sir.
1, 2, something like that, continuous numbers.
Yes, yes.
So then your problem is called as a regression problem. Basically,
Okay.
in machine learning terminology, your
Mm.
problem is called as a regression problem. So
Mm.
you need to use the best regression algorithms like XGBoost. Regrator will work for you. Okay.
Mm. Okay.
As of
Okay.
now, just
Mm.
take these notes and try to put your requirements with to my mail ID. I will share with you, and I will give you more information there, because it is
Yeah.
not useful for remaining people. So
Yes, yes.
I need to
Please,
continue.
Yes,
please,
sir. I
please.
think we should continue with our session.
Yeah, sure,
Okay, sir.
sure. Yeah,
Yeah,
yeah.
please,
Thank
sir,
you.
continue.
Yeah,
Yeah.
thank you, everyone. So yeah,
Sir,
so this is
please
the
hide here. Sir, stop sharing and hide. Please, can you click on hide?
yeah height. Okay, okay, yeah. Yeah. Okay.
Yes.
So
Thank you.
yeah, yeah. Thank you, everyone. So I feel everything is a valid question for you. I'm not like it's okay for me, but we need to see with respect to every audience. So that's what. If anyone have any specific
Sir,
question or
one
their own
question.
question, so please post
Sir, we
to
have
my mail
time.
ID.
Sir, we
Yeah.
have time
And
series.
one request from my side is that please make your question relevant to today's topic. It's a
Yes,
Yeah.
sir.
huge
Yes.
portion.
Yeah.
So if
Yes.
you ask from everywhere, so we cannot move further. So
Yes.
please,
Yes.
it's a humble request. Make your question regarding only convolution neural network, which we are
Yes.
discussing here.
Sir,
Okay, thank you
Yeah.
everyone. Please, sir.
we have time series data. Whether we can use it for this convolution neural network or only image only, we can take it for this convolution neural network.
Sir, image only, sir. Convolution neural networks works for only images.
Images, okay. Okay.
Yeah. That's it.
Only machine learning only we can use it for the time
Yeah.
series. Am I correct, sir?
Yes. Yes.
Okay.
Yes. Yes.
Thank you.
Yes.
Thank you.
Yeah. Thank you. And RNNs also. RNNs and LSTMs also works for time series data.
Oh,
Yeah.
okay.
Thank you. So, okay, everyone, it seems to be we need to start the slides. So, okay, so I hope everyone is clear with our understanding about the problem and what is we are going to solve and what is the purpose and all. So now let's go to deep understanding about what is convolution neural network and how this image classification works on convolution neural networks, how we can classify. Here you can see the one GIF file. So here you can see this is our input basically. So these are the convolution layers actually. So layer 1, layer 2, layer 3, layer some dense layer. Then this is the output. Here you can see this is 1 and this is 0. So final output is something like this 4. So something like this. I'm just for visualization. So here, so yeah, I'm just starting my session. So I request everyone, please ask the questions once everything is done. So I will give you some again specific time to pick the question. So please wait for the time and try to take your notes, note your questions and ask at the time. Yeah, thank you. So yeah, so now in this slides, I'm going to give you introduction as well as deep learning as well as training. Now back propagation, overfitting, regularization, dropout, and neural networks. And the slides are very heavy, so I'm trying to make very simple way to learn every audience. Okay, so basically in introduction, what is the image classification? Image classification is the task of taking input image and uh, outputting the class or probability of classes that best describe the images. So that is a definition of, or that is the introduction about the image classification. The image classification is something we need to give the input as a, means input input as a image, and we will predict the output as a class, or at least we need to predict the probability of the classes that best describe the images. If you give some car image to the model will predict, hey, this image is car. If you give something very different, but it try to predict the best probability of that class or that image. Basically, for human beings, this task is one of the first skills we learn and becomes naturally and effectively as a adult. So basically, so whenever you are whenever you are like a child, so if you see kind of new images or if you see anything, so it is hard for you to classify. See, whenever you saw the first time car, you don't know whether it is car or something, but after seeing the car multiple times with different images, I mean different cars, and you can came to know, hey, something shape is something like this, so then we can name it as a car. Or if you see the flights, so there are multiple flights are there. So based on the shapes, or based on our learning only, we are, as normally as a human beings, based on our experience and based on our learning only, we can classify and we can recognize the images. Basically, if you give if I will give you one image, that image is not giving any good information to you, then it is very hard to recognize the image, right? So so that is how our human brain works. So similarly, here also same things applies. Like image classification is whatever the image we are giving, so we need to classify the class is nothing but that tells about the image. Okay, so here what we are trying to do is we trying to recognize the patterns, okay, and generalized based on our we are basically as a human beings, based on our prior knowledge, we can say this image is something like this is the class or something like that. So here in machine learning, or whatever we are trying to do is we trying to learn the machine to recognize the patterns for each image. Okay, so that is the main concept. Okay, now let's see what we see versus what computer can see. So as a human beings, if you we are seeing a complete image of this cat, but computer can see only numbers, right? Only numbers computer can see. How one image is converted as a numbers? How? And let's discuss on that note. So basically this is what we see, means what as a human beings can see, and this is how a computer can see, means with respect to this portion of image. Now basically we have a different data set, and this we have a one very famous data set called MNS, MNIST. So basically this is the number data set. So there we have a 6,000 60,000 training samples and 10,000 test samples, and so basically whenever you build a classifier, or whenever as a researcher if you build a classifier, a new classifier, then the people are trying to use this data set and make the prediction and give the benchmark, something like that. So currently we are having the best accuracy around 97.99 percentage, something like this. Okay, so this basically this is one data set, and this is the this is the current best accuracy score. Okay. Okay, yeah. Now, yeah, here you can see exactly what is what I am saying, like what I am telling you. Like in this MNIST data set, if you look at the 8, the image of image 8, so the image is 28 cross 28 pixel. So like this is the total pixels, and you can see the numbers. If you see here, you can see everything is 000, but here only there is a numbers, and there is a some count is there. Here you can see somewhere it is 254, 254 to 182, 146, because see in the middle the box are very clear, like very white colored one, but it is something beside values are something very dull and light colors basically. So so this is the way to represent one image into the numbers, pixels basically. Okay, so this is the way how human can, means how human can see, and how to convert that human understandable image into the computer understandable image. So based on the numbers, and you can see the patterns, so based on the number pattern, so if the image is something like this in MNIST, then the machine learning will figure out, machine learning is trying to figure out the this pattern, this number pattern. So if you see the pattern, then it able to say, hey, this image is number 8, something like this. So this is the way how we need to convert image into the machine understandable way, means machine understandable format. So we have one more data set called CIFAR10. So all are means very popular and globally available data set. So in this data set we have images of airplane, automobile, bird, cat, deer, dog, frog, horse, ship, truck. So there are these data sets are publicly available, and this is provided by uh, uh, Toronto University. Basically, this is published very long back. So people are just using this data set to build a algorithm, and the researchers are using this data set to prove their algorithm is giving good results when comparing with the existing algorithms. So basically, these data sets are useful for benchmark purpose. Okay, so now let's see. This is with respect to color image. So previously so this is with respect to black and white image basically. So now let's see the color image. So we have a color image basically RGB, right? RGB. Basically our image is consisting of 3 color codes: red, green, blue. So this is the information how our image. So basically if you see the image black and white, it is something 2 cross 2. But if you see the image, it's something 2 cross 2 cross something, one more variable means one more dimension also there. So here we have a 3 dimensions, because the third dimension is something like this. I will show you. Like it's normally black and white image is something like this. but color image is something like this. So here we have this information like red, green, and blue. Okay, so this is about a color image. Here you can see. So with respect to single pixel, rows and columns and all. Okay, so this is how a image can represent. So image classification and text classifications are there. So, okay, I will come to this. It is make you some. So so let's see about how we already like we are having a clear idea how a image can convert or how a image can visible to the machine, right? So now let's looking to the convolution neural networks. So neural networks basically CNNs also takes inspiration from biological neurons basically. So here you can get the information like edge. So basically we have a three information like vertex, horizontal, and diagonal. So I will tell you basically this is a kind of information part of you. It is like a giving some information to you. If you want, you can browse also. You can get so much of information. You can read there and see. So it is like a very informative way. Like what is this by CNN takes biological inspiration from visualization vertex, and the visualization vertex has a small region of cell that sensitive to a specific region of visualization field. So something like that. It is like a information. So here you can get the information. So you can read it and you can understanding it. What is the information and all. Okay, so now let's see the a basic standard structure of one convolution neural network. So basically, this is the basic one standard end-to-end structure of one convolution neural networks. So here, this is our input, and this is the so here you can see this is the box. So this is the convolution feature mapping, and this is sampling, convolution, subsampling, fully connected. So just look at the architecture. I will explain you everything in detail. Okay, but presently just this is the complete algorithm and architecture for image classification. Okay, yeah. So now look into detail about what exactly happening. So I will tell you before I think. So here you can see that. So I just go back, but here you can see. So I already told you, right? Like already told you, like before that I will tell. Okay. So what it's trying to do. So here you can see uh, what this is trying to eat. This convolution is something splitting this entire image into multiple boxes, something like this. So like this. Okay. And understanding each block and figure out the patterns on each block. Okay, so here you can see that. So in original image, so if you take this portion of convolution, so this is the information. Yeah,
होल्ड हो गया था ना होल्ड रिज्यूम किया
yeah. Please mute yourself. I'm okay. Yeah. So here you can see that information. So here everything is 000. Only this pattern. So by this pattern only we are getting the some numbers. So which means the information is presented this 30, 30, 30, 30, 30, 30, something like this. So if you consider this portion, you can have something like this 0, 0, and somewhere around here some value, some value, some value here, some value here, some value, and something like this, and like this. So it's like a so what happens? So I will. Uh, so here you can see in detail, but now, so with some visualization, I will give you some good initial explanation. Then, so here you can see we are having some values, right? 0, 0 is there. So 0, 0, 75, 80, 80, 0, 70, 80, 80, something like we have a value. These values are based on our image information or image pattern. So what this convolution? So convolution is trying to take some kernel. So this is called as kernel. So kernel is trying to move across all the blocks and figure out the and compress or figure out the pattern inside it. Okay. So I feel now it is very means you can find difficulty to understand, but just watch this visualization once. So I will come back again. I will means we will go back and we will see what I'm trying to say. Yeah, just watch this visualization. So what I'm trying to do, every time I'm trying to map with each set of block and do the operation and put the value here. Okay. Yeah. So I will show you. Okay. So what happens? So if you see the complete image, if you see the complete image, uh, I'm going to put one kernel. Basically, this is called as kernel. So I'm placing one kernel here. Instead of checking complete image, I'm checking some block of with respect to the kernel. So I'm checking this block and this block and get the information here. Okay, so by using these two blocks and dot product, I found some line here, something like that. So uh, I'm more focused on understanding instead of technical perspective. I just want everyone to understand. So here you can see that there are multiple things. I think so. Yeah. So here what we are trying to do is we are trying to do the convolution operation. So this is our complete image. Inside our complete image, I think I will explain with the board. So okay, so let us just look at here, and I'm just explaining very in a simple way instead of directly going into directly equations and operations. I'm trying to explain in a very simple way. So let us take this is the one image, okay, and this image having some number 2 somewhere, something like this. Now what I'm going to do, I'm going to make some kind of kernel. So basically this is a one kernel. The kernel is something one matrix actually. So that is somewhere around 3x3 matrix, and I'm having some values on this matrix basically. So some values are there, and here also after converting our image into a machine understandable way, so we are having some values right here. Like we are having some values, some 0, somewhere around here, some 50, something like this. So some values are there. So what I'm trying to do, so this is 3x3 and this is somewhere around 9x9, for example, 9x9. Let us take 9x9 or somewhere around like this. So I'm going to place this 3x3 like this and do the operation to identify the information present in this set of block. Okay, what kind of information we have in this block. Okay, and make that information like do the operation here and place that information in another block, fresh means new block. So where I'm going to place here with respect to our first slide. So by this way, if you see in an entire image, if you see this portion, the information is something like this. If you see this portion, the information is something like this. So what I'm trying to do, I'm trying to find the information, means I'm trying to find uh, means information or visualization inside image. So that is so that is basically happening in convolution operation basically. So here what this convolution is doing, so if you take this part, so if you take this part, so it will take this part and do the convolution and find the useful information in this part. Okay, so here, okay, so now close that point here. This is our complete input image. In a complete input image, and this is the filter. So basically this image is somewhere around 5x5 and this is 3x3. So we are placing this this 3x3 here. So something like this. So this 3 cross 3 comes something like this. Okay. Place this 3 cross 3 comes something like this and do the dot operation. Okay. So then this is the results. Now what my point? So in a complete image, we are trying to find the borders, or we are trying to find the information within the image by using this filter and convolution operation. So we are using the convolution operation, and this is the formula basically. Just take a note of it. Don't try to by heart or doing anything like. So basically this 3 cross 3 matrix is called as filter or kernel or feature extractor. So what the purpose of this kernel is, so in our image, we have a 2, right? So what this kernel and this convolution operation is trying to do, it trying to find the feature, means features, how to say, how to say this image as a 2. So based on the features only, we can say, hey, if the image is something like something having these features, then we are going to classify as a 2. So for that, to find the features in an image, so this convolution operation is takes place. Okay, so that is the main purpose of convolution. So convolution operation is helpful to get the features in an image. Okay, so basically this 3 cross 3 matrix K, so it can be 3 cross 3, 4 cross means 5 cross 5, anything, 1 cross 1 also. So anything. So we are taking that convolution filters, like filters or convolution or feature extractor, and the matrix formed by slicing filter over the image and compute the dot product is called as convolution filter, convolved filter or active map or feature map. So this kind of, so so here you can see the dot product operation. So in visualization you can see here. So this is convolution filters basically. So in complete image, so we're trying to figure out the features. We are trying to fetch the features in the image. So how we are fetching, by using this equation and by using this dot product. So here you can see that. So this is the equation, convolution operation, and this is the filter, and this is the image. So here you can see. So every time, so here, uh, okay, I think it is not able to. Yeah, it lost. Okay, so yeah, so here what happens, I think I need to explain. Yeah, so here in an entire image, it try to see this box with respect to our convolution filter. So what happens, so this is the information. So in this information, we have this information something like this. So base take this information here and do the convolution operation and extract the information in the next image. So these extractions are important to get the to get the features in a each image. So that is going to happen here. So let us take with respect to this is like this, and with respect to this part, so this is something like this. Now here we have a, see, if based on the filters, if you apply the filters with value something like this, basically these values are constant, we are not, means if you use the values or something like this, then it is like a, so the outputs are something like this. So we are doing some operations, right? Like if you for identity operation, we are having the filters value something like this, and this is the convoluted image. Okay, so edge detection. So basically instead of see, if you want to say a image, whether it is car or bike, instead of checking entire car, it is very, so we are looking to figure out the shapes, right? Outliers means outlines, so that is called as edges. So basically using this filter with these values, we can detect the edges actually. So in each image we can detect the edges. Based on the edges only we can say most of the time, so most of the many use cases, based on the edges we can say mostly, if we classify any fixed fixed images or anything something like that, like if you classify bus versus car or bus versus car versus bike. So this edge detection is very useful in that case. So based on the edge detection, we can find the structure of bus every time. So So based on that filter, so based on this filter, we will extract that feature and we will train the model with that feature. Then whenever any new input comes, so it first try to extract the edges, and if the edges is matches with bus, so it classifies a bus. Matches with car, it is car. Bike with bike. So if it is bike, it is a bike. So at the same, so similarly, we have a sharpen. Sharpen is something making the input like very sharply, and box blur and Gaussian blur. So basically, there are multiple operations are there and multiple filter values are there. So you just need based on your use case. Okay. So these are the so basically this is about the convolution operation. So this is our input filter. So here you can see the convolution operation as well as, so here you can see this is our convolution channel with one. So we are placing this convolution channel here and we are getting the values here. Okay, something like this. So the convolution channel 2 here and convolution channel 3, and this is the value for that. Okay, this is the value for that and this is the value for that. Now if you combine all the values, then this is the final output value. So this value will tells the information, means extract the feature here. Okay, here you can see in practice, CNN learns the values from values of those filters on its own during the training process. So whenever I build a model and whenever I start the training, so this filter values, whatever the values we are making right in filter, like here you can see this values, right? Here you can see the values like 0, -1. So these values are updated automatically based on the training values. So in CNN learns the values of those filters on its own during the training process. Although we still needs to specify the parameters such as number of filters, filter size, padding, and stride during the training. So number of filters means how many filters you want, and what is the filter size, whether you want 3 cross 3 filter or 5 cross 5, 5 cross 5 filter. And padding is something like this. Padding is something if you use the 3 cross 3 filter, but if you want to see on a edge, so we need a extra one uh, column and row, right? Like one vertex, I mean, so one vertex horizontal value and vertical value. So this creating this extra column or extra vertical horizontal is called as padding. Basically padding value here, the padding value is 1. So yeah, okay. So yeah, so this is the information, okay, with respect to what happens in a convolution. So here you can see, so this is the kernel and this is the complete slide, and we are not using any padding, not straight. So this is the output value. So now let's look into activation functions basically. So what happens, so in convolution, basically convolution neural networks use ReLU basically. So I hope everyone means most of the people do not have idea about the ReLU activation function. So ReLU activation function is something, whatever the input you have, if the input value is something 0, or if the value is minus, then it is 0. But if the input value is something positive, then it's going to be positive, something like this. So here you can see the output is the maximum of 0 comma input. If your input is somewhere around x, for example, if your input is x or something 8, so then max of 0 comma 8 is 8, right? But if your input is somewhere around -5, then max of 0 comma -5 is 0, which means it will always try to find the positive region value. Okay, so basically ReLU is a element wise operation applied for each pixel and replace all negative pixels with negative pixels values in a feature map by the 0. Because if you put the minus in this equation, like max of 0 comma minus, then 0 is the maximum value, right? If you compare with minus value, so that is just basically that is happen here. The purpose of ReLU is to introduce the non-linearity to the network. Non-linearity is nothing but, so if you find an so what is this linearity and non-linearity is, like I will tell you. See, for example, I have a two classes. I have a two images and two classes, something like this. So if one image is placed here, that is A image is there, and A image is there, and B image is there, and B image is there. Something like this. If I find the if I draw this line, then I can classify whether the I mean if something output is present here, is make it as a class A, and if something is present here, is make it as a class B. Correct. So basically, these kind of problems are called as linear problems. So if we have a problem something like this, A and B, again somewhere A and somewhere B. So is it can you able to draw the map, very simple map? It is very hard, right? If you draw here also, it is not good. So what you need to do, you need to find the out non-linear out boundaries. So then only you can classify. So this is basically the difference between linear and non-linear. So in real world, most of the classifiers are non-linear classifiers only. So there is no linear classifier. So but in convolution neural networks, if you are looking for non-linearity, which is nothing but so whatever we discuss, so then we need to apply the, so this ReLU will provide that non-linearity to our convolution layer. Okay, so here one more activation, like here you can see this is the input feature map. So black is equal to negative and white is equal to positive value. So here you can see some black color codes are there. So something like this. There is a three colors are there basically. This one is ash. There is no information on ash color. Like ash it means something like this. Background is ash, and there are white colored things are there, and some black color things are there. Something like this. This is the black color things. So by using ReLU, we can eliminate those black means negative values. So by that way, we can rectify the feature map. So other linear or non-linear functions such as tan h is there, sigmoid is there, also be used instead of ReLU. But ReLU is found outperform better in most of the situations. Basically, out of all this tan h, sigmoid, and ReLU is giving very good results and very good performance when we are comparing with the tan h as sigmoid. We have a leaky ReLU also. Leaky ReLU is a variant of ReLU, but it will take care the negative values also, something like this. Very minimal, very minimally it will take care, but in positive region it will take care. Like yeah. So this is about a non-linear layer. So like non-linear with the help of our activation function. Now let's see the pooling layer. So the pooling layer is a downs samples and value spectrally independently in each depth slides. So here the pooling is something. So whatever we are means we are making na, like 224 cross 224 cos 64 is going to make the is going to reduce, like pooling is something downsampling our input, like we are having this much of input, so represent the same input with a less size, something like this. So 224 image is going to represent as a 122 downsampling. The most common downsampling operation is max. If you apply the max, if you give raise to max pooling, and here you can shown with a stride of 2. So basically this is here you can see in this image. So instead of, so here you can see this is the operation, right? So whenever you apply the operation here, then max pool with 2 cross 2 filter is slide 2. So then this is the final sample. Okay. So this is with respect to pooling layer. Pooling layer is something downsample the value. Okay, using the operation called max. So we can make it we are saying it as a max pooling. So let's see the fully connected layer. So what is this fully connected layer is, I think most of the people have idea about fully connected layer. So what this fully connected layer is, so yeah, here, so here, see, for example, I have a nodes basically. So this is the 3 nodes, and I have a 2 nodes in my next layer. So what this fully connected layer is, every node is connected to each other. Like, so if the layer is something like this, then it is called as a fully connected layer. So here we are discussing on that. So the neurons are in fully connected having, sorry, yeah. So here, here you can see that information. So so here this is the fully connected layers. So till now everything is convolution layers only. Like, see, this is our complete information, our input information, like three colored rainbow color, like red, red, green, blue. But this information, like this input is make it as a with the help of our kernel. So we are making the so we are outputting something like this, means making this thing to here. So based on ReLU activation, so again we are doing this pooling. Again, this pooling things are applied here, and again this we are applying convolution, and again pooling things are applied here. So something like this. These operations are applied until unless we are getting uh, good features in an image. So if we are until unless we are able to get the good features of images, okay, this operations will continue until we are going to get a good features. Okay, so that is, so this is the very high level uh, information. Yeah, now let's look into architecture level. Yeah, here you can see basically. So here with architecture level, so this is the input, and this is the convolution with ReLU activation function, and again we have a pooling. And after all these operations, then we are going to give this as a feature input, and to our fully connected layer with activation function as a ReLU. So finally this will provide the output. So it is something like this: input, convolution layer, and fully connected convolution layer, sorry, fully connected layer. This is the one way. This is very simple linear classifier. But input, convolution, ReLU, fully connected layer is what we are looking for. And this is the kind of uh, single convolution, and this is a complex or deep convolution layer. So this structure means, if you are use one convolution layer and one pooling layer and one fully connected layer, so then it is called as a simple convolution layer. If you are using some set of or some bunch of convolution layers, some bunch of uh, pooling layers, and some bunch of, means some number of fully connected layers, then it is called as a deep convolution layers basically. So all are stacked over each layer basically. Okay, so here you can see, so this is our input. So this from this input, by using our convolution operation and convolution layer, so we are going to get the features. So here you can see, so this is one feature, and this is one feature, one. Again, we are applying ReLU on this, and so this is the final feature from this layer, this complete layer. And again, we are giving this feature to one more convolution operation. Again, so this is the that layer. So after this, again we are giving this values to the pooling layer. So the pooling layer will optimize the features, and again that will give into the one more convolution layer. So here you can see again that is given to the one more another convolution layer. Again we are doing a pooling. Now here convolution and pooling. So finally we are having the fully connected layer. So based on the fully connected layer, we can classify our image. Okay, so here you can see that. So this is the one block, second block, and this is the three. So here one more block. So here you can see convolution, convolution with ReLU. Okay, with two sets. It's two sets, and followed by pooling layer. So followed by pooling layer. So this entire thing is considered as a one block of means one standard layer. So we are using three layers. Here you can see. So this is the one layer, two layer, and three layer. Later we are using fully connected layers. So at this time, at this point of time, we are going to have a complete information about the features in our image. So then, so these features are going to feed to the fully connected layers. Then fully connected layer will take the features and try to predict the class based on the features. So here you can see this is the car, and this is finally it is predicted as a car. And you can see it is the probability of truck, the probability the percentage of truck, and the percentage of aeroplane, ship, and a horse. So this is basically a very uh, good level of understanding how convolution works. Okay, now yeah, in summary, the CNN is in a simplest case of a list of layers that transfers the image value into the output value, which means try to get the features in a image. And there are distinct types of layers we have. So we have a convolution layer. In complete convolution neural networks, we have a convolution layer and ReLU activation function, pooling, and fully connected layers. So these are the main types of layers we are using. Okay, each layer may not having the parameters. So sometimes, so in these layers we have the parameters, but ReLU activation functions are activation function, and pooling does not have the parameters. So there is no requirement of means some layers require the hyperparameter tuning, which is nothing but what is the convolution you have, what is the fully connected, how many neurons we need to take in one fully connected layer, how many number of fully connected you want, how many number of convolutions you want, and how many number of fully pooling you want, and what is the size of pooling, and what is the size of convolution. So these things are hyperparameter tuning. So but in ReLU there is no hyperparameter tuning, but in this layers we have a hyperparameter tuning. So yeah. Okay, so this is the summary about a simple means a very I'm just targeting to understanding everyone, every person can understanding. I want to understanding every person by using this simple explanation. So yeah, so here this is the summary and this is the information about a convolution neural network. So you can see with respect to equations or with respect to operations in detail whenever if you if you are understanding those points, then you can go with the equations, how the equation is executing, like how the operation is executing and all. But as of now, I'm request everyone don't take everything at a time. So try to take this notes, whatever I explained. So later you can go in detail if you are clear, like if you are clear. Okay, but whatever we are discuss is enough to understanding a convolution neural network. Anyone have any question till now? I will ask I mean, I'm taking some questions. So then later I'm going to start one more topic. So this is all about a convolution neural networks, and all like. So I'm just looking at uh, yeah. I think yeah. So any raised hands? I think one hand is raised. Uh, Gaurav, you can unmute and ask your question. If you have a question, you can unmute and raise. ask your question. Otherwise, you can. Yeah, if anyone have any question on convolution neural network or whatever we are explaining in the slides, anyone has any question, doubts? Actually, in slides, I make very simple and very informative. Means I almost everything I placed, like I added all points in the slides only. But still, I think it is not very easy to understanding everything in a one way. Means in a very limited time. So yeah. So I'm looking for anyone have any questions so far we discussed. So we will discuss that. Suban is raised the hand. If you have a question, please let me know.
In the PPTs for our input channel, we are showing it as a matrix with some numbers. So how are we getting these numbers actually?
Yeah,
The input value.
yeah. Here you are asking about this one, right? Uh, this how to convert the image into these numbers.
Yeah, these numbers. How is that? I mean, what logic? Based on what logic we are
Yeah,
getting these different numbers?
yeah. Basically, we have a in Python we have some libraries. So if you give the image as a input to that library or input to that, then that will convert that image into the machine readable file. Here you can see. So so here we try to read the image and try to see the color code also, and extract the numbers from that image and append in the numpy array. Okay, so that is take care by the libraries basically. So we have
Okay, okay, yeah, got
very
it.
yeah, we have a means cv2. So if you
Right.
in cv2 we have a mread is nothing but if you give the image as a path, like if you give the image path here, then it will read the image as a numbers in terms of numbers. It can able to read the image as in terms of machine understandable numbers. So we can take the output from there and we can work with our remaining things whatever we discuss.
Yeah, thank you. I got it, sir.
Yeah, thank you. Yeah, uh, in coding section I will explain in detail if still required. So means I will show you what exactly happening. uh, N- Niyati, yeah, please go ahead with your question.
So I wanted to ask that to train our model, do we use the same data set that we have, or like how do we train the model?
Yeah, train the model. I will show you how to train the model. Means instead of answering now, I will show you with real time experience. Means real time data and real time way of how we are training model. Means that question means your question may cover soon.
Okay, sir.
Yeah. Sorry, like I disconnected and come back. So please share. I think I have. Yeah, I think now my screen is visible to everyone. So can anyone confirm?
Yes, sir.
Yeah, yeah.
Yeah, yeah. Thank you. So okay, so so far we discussed about theoretically how the things are happening. So so far we discussed. Anyone have any questions? Please let me know. Otherwise, I just wait for 2-3 minutes. So if no one having any question, then we will move on to the next topic. I'm not able to see any raised hands, so I will continue. Okay. Yeah. Yeah. So till now we saw what is the image, first point, and how a human being can see the image and how a machine is able to see the image. Okay, that is the second point. And what is this convolution neural network? So what this convolution is doing means what is the purpose and how it is doing, what is the operation is it is using, and what is the architecture it is following, and these kind of information we discussed so far. So I'm just revisiting again. So this is very, very important. So the main purpose of today's session is all about this only. So yeah, so this is our, basically this is the complete architecture. So this is the input. So this is our convolution feature map, which is nothing but our convolution layer. And this is our pooling layer. And again, this is the convolution layer. And we have a complete fully connected layer. So this is a pooling layer, and we have a finally fully connected layer. From our final fully connected layer, we are taking an output. So basically, this is the one simple and standard structure network architecture of one convolution layer, convolution neural network. So basically, this is the convolution operation. So here you can see the convolution operation. What happens in the convolution operations? So in convolution operation, we have a concept of, we have a one matrix called filters or uh, kernel, or we can say feature extractor. So this kernel is every time this kernel is going to the image and try to do the multiplication, means means a dot product operation and extract the information based on the filter and based on the kernel, means based on the information present here, it will extract the information and it will provided to the next, means it will provided as a output again as a image only. That is called as a feature, means feature extractor or feature image. So this process is called as convoluted feature or active map or feature map basically. So now here you can see this is the example. So this is one set of one block here, and this is how the operation is going on and what we can what we can see. And with respect to convolution operation, we have different feature maps. So the feature maps are based on the filter values. So if you want identity, if you want an operation as an identity, which is nothing but just whatever you are given, I just want whatever I want, means whatever I given, I want that one only. So in that case, it is identity. If you want to find the edge detections, which is nothing but in your images, is there any edges are there inside the image? So that is called as operation edge detection, sharpness, blocks, and so there are so many operations are there. I mentioned this only, but we have more operations also. You can browse and you can get that information. Okay, yeah. And now, yeah. So here, this is the image how it looks. So here you can see how one kernel channel is going here and place here and do this operation called dot product operation and extract the information as like this. So something like this. Here you can see during the training process. So in training process, it the filter values are adjustable, are updated in a such a way that try to fetch the features from the images. Okay, so and only we need to specify the few parameters called number of filters, filter size, padding, and strain before training. Okay, so here you can see some visualization how it is happening and how it is doing. So whatever the information present in complete image is going to available in this image, in this slide. Here we are having somewhere around 5 cross 5, right? But this 5 cross 5 image information is going to available within 3 cross 3. So basically it's try to extract the features. So this is the way, like here it first it, so here you can see, so in this so it goes here. Whenever you find any like whenever you see this blue shaded, right? So what happens, this what it's trying to do is it trying to take that matrix and so take this matrix and do the dot product, and whatever the result is coming, and that is the feature. So that is the operation actually in convolution. That is a convolution operation. So we are having one more one padding and strange also there. So we need, so that is also required here. So and we in convolution neural network we are using activation function as a ReLU, because every time we want to see in a positive region. So that's what we need a ReLU. And ReLU also useful for introduce or provide the non-linearity to the neural network. So non-linearity I already told you. Whenever if you are able to if you are able to divide two group of numbers or two group of values with a single line, then it is called as a linear. But if you are not able to determine the two classes with a single line, it is called as non-linear, which is nothing but all values are very close and very unsystematic manner. So you need to find the very accurate boundaries to differentiate the classes. So that concept is called as non-linearity. By using ReLU, we can provide the non-linearity to the network. Okay, and here you can see what exactly the ReLU is doing. Okay, so and one more thing, ReLU is providing good performance when comparing with other activation functions like tanh and sigmoid. And here you can see with pooling layer is something whatever we are provided with 24 means 224 cross 224 cross 64. So we can place or we can get the information in a compressed manner, like means instead of taking this big image, make the big image which is without losing the information present in the image, but make it in a smaller image. So make it as a small by using the operation called max, down sampling operation of max. So this is called as pooling. Okay, so this is the by the end we are having the fully connected layer. So the fully connected layer is a final layer which is just before to the our output layer. So but so whatever the convolution neural network extract the features, right? So the convolution neural networks, so in this complete architecture the convolution try to learn the features. So feature learning, so whatever convolution ReLU pooling, convolution ReLU pooling, everything is try to learn the features. Future learning, once the future learning is done, so we are flatten the values and give to the fully connected layers. So then based on the fully connected layers we are going to get the output layer. In the output layer we are going to get the our output classes. So basically this is the structure. Okay, so here you can see the different architectures. If you have an input and fully connected layer, it is a very simple linear classifier. So if something like this, it is a simple convolution. If something like this, then it is a deep convolution. So basically, it's a kind of deep convolution neural network only. So we are having a three layer convolution with pooling layers, like three level convolution ReLU pooling level layer. So finally connected with a fully connected layer. So these are the things we have in a summary. So I'm explaining everything in a very simple manner. We can explain these things in a very detail also, but I'm not focused on the things because I want to reach everything to all audience, not a specific audience. Means if already if someone have a more idea already, then they will go very in detail wise. But as of now, take this beginning to intermediate level knowledge, then work on your advanced like now let's, if you are more interested and take let's go behind and do see in detail. Okay, but this is enough to understand this knowledge is very good enough to understand the how convolution neural network works. uh, okay, so we are having this kind of layers, types of layers, and some layers having parameters and some layers having hyperparameters. So this is the information and a summary. Okay, so this is the information, means this is the summary. Now let's look into some successful convolution architectures. The first convolution architecture is latent. So latent 5 is a architecture that is excellent and first architecture for a convolution neural network. So this is our input image, and this is the convolution V1 pooling layer and convolution pooling and flatten and fully connected layer and our output layer. So basically this is I think this is published in very earlier, like in 2010, somewhere around, I think so. Next we have a AlexNet. AlexNet is very famous. So it is published, or it is published in 2012. So it is basically, this AlexNet is something. Here you can see we are having, this is convolution 1, layer 2, layer 3, layer 4, layer 5. After 5 layers of convolution, we are using fully connected layer as a 6, and fully connected layer as a 7, and fully connected layer as a 8, and this is the final output layer. This fully connected layer 8 is the output layer. So basically, this AlexNet is proposed on image data net. ImageNet is something very huge and most popular data set which is available in this AI field. So in this data set, we have a million images, million number of images, and we are having 1,000 classes. So we have the number of classes is fixed. So we are having 1,000 classes, and for the 1,000 classes, we are having 1 million plus images. Okay, so that data set is called as ImageNet. So wherever, if anyone, like if you see Google research or Amazon research is publish any kind of neural network architecture or any model, so they need to prove on a popular public data set. So ImageNet is the first popular public data set. Whenever anyone try to prove their algorithm is overcome the, or provide the good accuracy when comparing with existing, so they try to prove with the ImageNet data sets. Okay, so this AlexNet is proposed in 2012, and this is the structure. So this block is the kernels, basically kernel and operation, and takes here. So later we have a VGGNet. VGGNet is proposed, I think, in 2013 or 14 somewhere. So here we are having, so here you can see the convolution with ReLU, max pooling, fully connected with ReLU and softmax. So same thing. So this is our original image, 224 cross 224, 224, 3, and make that image into 224 cross 224 cross 64, then 112 cross 112 cross 128, 56 cross 56 cross 256. So something like this. So till it comes, and finally this is the output layer. So basically, these are the architectures basically. So here you can see the difference. This is AlexNet, and this is VGG 16 and 19. So in AlexNet, so input and one first convolution layer with 11 cross 11, and second convolution layer with 5 cross 5, then pooling layer, then convolution 3 cross 3, pooling, convolution 3 cross 3, convolution 3 cross 3, pooling, then fully connected layer, fully connected layer, fully connected layer, and softmax. Means the output means we are using multi-class label, right? So we are using activation as a softmax. Okay, softmax will give what is the probability distribution across the all classes. Okay, with respect to one. If you have a, means in our case we are having 6 classes, right? Out of 6 classes, which class is going to have a more probability? Like for example, second class having 0.7 probability. So and remaining 0.3 is distributed among the 5 remaining classes. And if you sum the complete means if you sum all probability distribution, then the value must be 1 only. So that concept is called as softmax. Softmax is the activation function is try to predict the probability with respect to each class, and what is the maximum probability class. So that is called as softmax activation function. So here you can see the VGG 19. So there is no huge difference. The only difference is the number of layers and the different parameters only. But you can see that information. So only there are 2 layers are extra. So then yeah, and how this back propagation is works here. So first is initially allocate the weights and bias, and it try to compute the cost function. After computing the cost function, then it try to upgrade, it try to update their weights and minimize, means it try to update their weights in a such a way that to minimize the loss. So learning rate is something we need to give, how frequently we need to learn, and overfitting is something we need to take care. Like if you overfit or something, hey, if something comes something like this, you are blindly say this is the class. So if you overfit your model with more information, more and more and more, then it is very hard to generalize. So for example, see, for example, I need to find one. So if I have some dots here, some points, something like this, like this, like this, like this. So I want to develop one equation. One that equation is enough to means I want that equation to right. So if I make this equation, if I somewhere here I want something predicted here, so then something real prediction is something here, but here. So but if you are making something like this, then it is something generalized way. If you overfit this equation, or if you overfit something like this with each point, then what happens? Even though the value is present here, but it is shown here. So there is a huge difference. If something is present here, if something is present here, what is the distance between these two? Very less, right? But if you see the overfitting, there is a huge difference between overfitting line. So it's something like that. So if you try to learn, if you try to train your model with more and more, then it is going to be a overfitting. So it's not able to say anything on a general way. So that is the one problem. So that problem is called as overfitting. We need to take care that one also.
Not checking. Why checking after this and that? Who will check? Granta for you. Everything I
Hello.
gave you.
Yeah, hello. Yeah, and for overfitting, we are having the regularization. So I will tell you what is this regularization during programming. If I say also, it is not easy to understand. So now let's see the experiments. So basically, these are the like malaria recognition. Something if you have an image of malaria, so then it can able to say whether we are infected with malaria or not. So here you can see. So this is the image, and this is the AlexNet, and this is the final output layer, and final output layer will evaluate positive, negative, something like this. Class are there. So malaria recognition. This is the feature map learned. So this is the feature map. So here you can see the feature maps. So feature maps and things like this. So like thin blood. Like if you give the input and feature. So if any feature is matched with the feature map, then based on the label with that feature map is going to predict it as that label. So something like that. So here you can see the results. So plant resignations, and here this is the very deep convolution layer is something uh, very applying more number of layers and doing more deep I mean this is something different, so I'm not going to discuss deep convolution neural network. So GoogleNet also something say similarly like this, but it is proposed in means this AlexNet is proposed 2012 and all like VGG and AlexNet is somewhere around 2012. In 2014 we are getting GoogleNet. So Google published the GoogleNet. So this is the GoogleNet architecture, and here you can see the GoogleNet architectures. So in 2015 we are having ResNet. So this is also something different, but if you see in detail, like if you see very detail, so inside the architecture wise it is different, but layer wise still we are using convolution layers only. But number of convolution, the way of using something is different, but the convolutions are still there in ResNet also. So this is the information. So here this is the final information. So as a so like this is what exactly happened in a convolution neural networks. If you give the image something like this, so then the convolution is the convolution neural networks is trying to see each block and fetch the features from each block, something like this. So this each blocks is stored, and if we find any feature block with this, then it is going to say, hey, this pattern is present. So with respect to this pattern, this is the label. So this is the way how a convolution neural network extract the features in an image. Okay, so that's it, and this is all about our presentation. Means theoretical knowledge. I hope everyone is clear. I just want to give you a break. So I think we are already. Uh, I think we now it is 6:18, right? So please take a break. Organizers, can you please respond on this? We need to give a break, right? Chatterjee sir, like we need to give a
Yes,
break,
sir. We
right?
need to give a break for 10 minutes.
Yeah, sure. Take the break. After the break, I will just recapture the things and we will work on hands-on how we are going to use our convolution neural network with Python programming with a real-time problem, whatever we discussed in a part one. So I'm going to show you. Okay, and I will meet everyone again on. It's now it is 6:20 nearly, so we will meet again on 6:30. Okay. Yeah. Thank you.
ಹೌದಾ ಹ್ಮ್ 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 ಯಾರು
Yeah, hi everyone. I hope all participants are written. Yeah, so I just want to summarize again what we discussed. So in our first part we discussed about our problem statement is something like we need to create, we need to find a model or algorithm that can able to classify our input image into the classes, respective classes, right? So this is our problem statement. So then for the problem statement, we saw the convolution neural networks concept and how convolution neural network concept is able to solve our problem, right? So these things are done. So far, anyone have any last doubts? If no, with respect to these things, then I will start a coding session, hands-on session, how in Python, how we are going to solve that problem using our Python programming language. Okay, so if anyone have any question, please raise your hand.
Sir, your voice is not clear. Sir, your voice is not clear.
Yeah, I think is it clear now?
Sir, now it's clear.
Okay, clear.
Oh, sorry. Some mic issue. Yeah. So in first part we discuss about our problem statement, right? So we need to develop an algorithm or model. This model is taking the input as a image, and finally we need to predict the probability of what is the category it is, what is the class of that image, right? This is our problem statement in what we discuss in a first part. And we have a data sets, we have a 3 data sets, and our evaluation metrics is accuracy, correct? So for this project, or for this purpose, we learn about convolution neural networks. It's a kind of neural network basically. Basically, in neural networks, we have a basically fully connected neural networks, convolution neural networks, recurrent neural networks, LSTMs, uh, auto encoders. So many neural networks are there, but convolution neural networks are highly means completely with regarding image input, image data sets. Okay, yeah. So we are going to, so for our problem, convolution neural networks are going to solve our problem. And we saw about what is the image and how we taking the image, and what is the how the convolution operation is take place, and all information how it is happening, and how the convolution neural networks extract the features in an image, and what is the architecture, and what are the existing and successful convolution, convolution neural network architecture we have, like LXNet, VGGNet, and so and we saw the training also, like so this is the complete information, and this is the information we have. And one more point, these are the reference I took for this presentation. So all slides are basically author, those people are the author for the slides. Okay, yeah. uh, okay, so we are understood about our problem statement as well as the uh, algorithm what we are using, what we are going to use, that convolution neural networks, how it is works, what is the architecture, and what are the successful convolution neural networks. I hope everyone is clear till this point, whatever we discuss. Can I take that note? Can I take that, like everyone is clear with whatever we discuss with part one about our problem statement and convolution neural network, how our problem statement is interlinked with our convolution neural network? Can I take it as a yes? I think everyone understood, right? If anyone have any doubt regarding this, let me know. I mean, raise a hands and let me know. I'm just waiting for 1 minute. If anyone has any doubts, I will answer. So otherwise, we will continue with our hands-on session. There we will see how we are going to solve, how we are going to use our convolution neural network and solve our problem. Okay, yeah, yeah, yes, please go ahead. I saw you raise the hand.
Excuse me, sir, can you describe in brief what is the work of CNN? Actually, I have joined late. So,
No. What? Can you please repeat again?
so what is the basic idea behind this CNN? So, sir, can you describe it in brief?
Yeah, I think yeah. So in slides it is clearly means in slides I have everything is mentioned. So I'm going to upload the slides, all the slides here. I think the slides are enough. Like you can get complete idea using the slides. And regarding session, regarding also there. Organizer, can you confirm that? Like regarding also there, no? Yeah, I hope
Time
recording is
is
also there.
running, sir.
Yeah.
Time is running, so
Yeah,
Okay.
time is run. Yeah,
yeah.
time is running. That's what I want to inform about. Like we have a recording and we have a slides. So you please take the recording and slides so that using those resource you can understanding what we discuss. Okay.
Okay,
Yeah.
sir.
Yeah. Thank you. So let's look into detail about how we are going to solve our problem. So before starting my problem, basically we have a standard template, like any whatever the model or whatever we are whatever the uh, problem we have in ML, so we need to take standard steps basically. So I just mentioned those steps here. So the first step is we need to finalize the library, or we need to fix the library or frameworks required in our complete project. Libraries, that is the first step. Libraries in a sense, for example, we can solve. Basically, we have a in neural networks we have a two frameworks actually. So one is TensorFlow. So TensorFlow and another one is PyTorch. So, but it is up to you. Using any one means using any framework, you can solve the problem. Means we can use, but up to you, which is most comfortable to you and most easy for you to write a code and work with the framework. So that is up to us. And important libraries, what are the required libraries you feel in your complete project? We need to import those libraries and then load the data sets basically, or in normal sense we need to collect the data sets. Data collection and gathering some data collection is there, but basically this data collection is not required because they are already provided the data set. So the next step is load the data sets. Then after loading a data set, we need to do the data analysis or EDA, exploratory data analysis, like visualize the data. Now, after doing this, then we need to do the data pre-processing, which means we need to convert the data into machine understandable format. Okay, whether it is text or whether it is image, we need to take care of that. Okay, yeah. Now, next we need to build a model building. So where we need to use our algorithm, whatever we learn. So like we need to use our CNN here. Now then we need to do the training. Then we need to do the prediction on a feature data set or test data set or feature data set, feature samples or feature data sets. Now, now do the evaluation. Evaluation is something how our algorithm, whether means our CNN things are which our algorithm, what is the accuracy, or the evaluation can be anything. Like in this scenario, the evaluation is accuracy. You need to see the accuracy. So once everything is done, then do the deployment or production in industry, basically deployment or productions. So these are the primary and mandatory steps, standard steps in each and most of the machine learning or computer vision problems. Okay, now let's look into first by using that. So first let's import the required libraries. So in this project, I required NumPy, scikit-learn, Seaborn, scikit-learn, Matplotlib, and CV2, computer vision 2, OpenCV we can say, and TensorFlow. I'm using a framework TensorFlow and DMD. Okay, so here I'm just running this. Basically, this is Kaggle platform, Kaggle notebook environment. So they are already imported these libraries. Sorry, they are already installed these libraries. I'm just importing these libraries. If you are using your own system, you need to take care of and take care about the installations of all libraries. You need to install all required libraries before importing. Okay, but this is actually online platform. I'm just using for demo purpose, so that's what. But if you want to make your project your own, or means your own personal project, then you can make use of your own pieces or somewhere in a very secured way. Okay, so here this is the importing required packages, and now I'm going to load the data sets. Load the data sets. Okay, so in data sets, so before that we have a classes basically. So I know the classes. So the classes are mountain, street, grazer, building, sea, and forest. These are the classes in my complete data set. And here you can see the class and their means so this is basically, this is the text, right? So the machine is not able to understand this text. So that's why we need to make it as a numbers labels, which means if you see for each name, we are giving like mountain as a 0, street 1, 2, 3, 4, 5. So which is going to feed to the neural network, and length of the model is the NB class. Okay, and we are defining the size, image size. Image size is what is the pixel, 150 cross 150. This is our image size. Okay, so now we are doing that information. Now let's look into the loading the data sets. Basically, our data sets are present here. So here you can see this is the input, and data, under data we have an input. In input we have a data sets. This is the platform basically. That's why the data sets are placed here. But in your own system or own PC, you need to specify the path where your data set is present. Okay, but here this is the path for this data sets. Here you can see here this is the path. So I'm just giving this path, and this is the output. So here what is trying to read is it trying to read the image as well as the label. Label is here, this is the label, building is the label, and it trying to read the image. Read the image, convert the image into the numpy. So here you can see that information. So here by using CV2, it read the image, and so whenever it do the read, like here you can see what is the uh, CV2 image read. What is the purpose of CV2 image read? And you can get to some idea what is that function is doing. So this method loads the image from specific path, and if the image cannot be read because of missing or improper permission, then only it will returns. So what it will returns? It returns, this method returns the image is loaded in a specific path or not. So we're trying to read the image basically. So that is we are doing with CV IM read function, and make the color code also and resize the image. And after doing all these things, so I'm going to append each every image into the image file. So after that I'm going to finalize the images. Here you can see. So this method will returns the that information. So here uh, so so yeah, now finally we have this information and we have the output. So whenever you run this thing, then here you can see here this is load image. So we are calling this load image function. Basically we write as a function, so we are calling that function. So that function will returns output with image, training images as well as the labels, testing images as well as the labels. Testing images which is useful for validation purpose basically. So prediction is a something we need to do the evaluation, we need to check. Okay, so as of now we are having training images as well as the test images, so which is just loading here. You can see it is loading here. It takes some time, so we need to wait. Yeah, actually we wrote everything in a function. So what is trying to do is here this function is executing basically. So going to this path, and in each path go to each image, and means each class. In each class going to each image and read the image and convert it into numpy array, which is the numbers format with color code. Then put that values in a image, and label also in the respective labels. So this is here it is doing that task. So now we have a so now if you want to see, you can see this, like you can see train images dot label. So here we can see that. Yeah, so you can see the yeah, so here this is with respect to each. So basically this is 4 cross 4, but if you want to see with respect to one image, so this is the how image is. Like here you can see with respect to image, basically what I told you na in a starting, like I told you in a starting, like we are having three layers, right? It's like three colors, right? So that's why it is 3D, and each the 2D represents pixels like 150 cross 150, and 3D represents a color code. So this is how images look like. So here you can see the numbers. So finally we convert image into the numbers. Here you can see. Okay, so this is the way to convert image to numbers. Now after that, so basically these images are stored in a very sequential manner. So what we need to do, we need to split the means shuffle the images. So because if you feed this input as this, then model is trying to remember the things. So that's what I want to shuffle the inputs. Then only my data is very good for generalization. Okay, now I'm doing the shuffling. So shuffle is a one function which is so I'm just taken the shuffle from sk like scikit-learn utilities. From scikit-learn utilities I'm imported a shuffle function here, shuffle function. So I'm using that shuffle function here. Okay, so now after doing that, let's explore the data set. Okay, and now we are going to see the how the data set is looks like. So here you can see the number of training samples are, with respect to training data, we have 14,034 samples are there with training data, and testing data 3,000 samples, and each image having the size of 150 cross 150. So that is 150 150. So okay, so this is about the information with respect to our data. Now let's look into the distribution with respect to each image. Means what is the count with respect to each image. So here this blue color bars represents the training count. Like for example, for mountain class, we have a training images of 2,500. So that many images we have in training data set. In testing dataset, or in testing dataset, we have a 500 and mountain images samples. So something like this. So by using this graph or by using this bar chart, so we will get that information. Okay, by using that visualization. Now with respect to each class, what is the distribution? So here the distribution also seems to be very close, very good. Like every class having almost equal number of images. Okay, so that is so by using this pie chart we get that information. Correct. And now let's scale the data. Like our data is something like our image, like whatever the numbers we converted na? Like in here, uh, here we are converting the image into 0 to 255, like 0 to 255, right? So we need to scale that value with respect to 0 to 1. So for that purpose, I'm just dividing entire values with respect by 255, which means instead of big numbers, like if you see the comparison between 1 like 5 and 150, there is a huge number difference, right? 5 and 150. If you see the same thing with respect to small numbers like 0.5 with respect to 0.75, there is a very the comparison is very good for machine. Like we need to do the scaling instead of giving real numbers. Scaling helps us to learn in a very efficient way. So that's what we are giving scaling. Now I'm just visualizing the data. So let's pick some random image and visualize that image how it is looks like. So for that purpose I'm writing one function, display random image. So this display random image is used to see any means how the images looks like. So here you can see. So for example, this is the image and this is the image number, and this is the image class, and this is the image. So this is mountain image. So here you can see by you. So it's something like visualizing the data basically. So whatever I mentioned in the steps now. So like data analysis and visualization. So something like this. The data pre-processing already we done. So here this is also for so this I'm applying the same function, but this time I'm using 25 images with 5 cross 5 grid. So here you can see the grid. So this is building, this is building, this is greaser building. building research and CE forest. So these are, this is the way to visualize the images for our understanding. So now let's look into building now let's look into building a model. So here I'm just using so we are building a easy model composing of various layers. So I told you na, in slides, it is I explain everything in a very clear way, like so now we are taking the input. So now we are going to feed this image to first with convolution 2D. So for that purpose I am building my model with convolution 2D as the first layer, and then max pooling 2D, and then again convolution 2D and max pooling 2D. After this two layers, after two set of layers, then I flatten the input. Like I flatten this two-dimensional to one-dimensional, and I'm going to give that input. Like here in a slides, you can see that whatever here whatever the network use on so that only we are written in coding. So here you can see uh, this is the input, and this is our convolution with ReLU. So here you can see that thing. This is the convolution, and we are inside only we are using a ReLU activation function, and this is our convolution size, and this is our kernel size of 3 cross 3. So this is the parameters, and this is our convolution grid size. Okay, so here you can see, so this is the convolution grid size, and this is our kernel size 3 cross 3, and this is with respect to one convolution with ReLU, one layer of convolution with ReLU. Again we are going to apply the pooling. So pooling, for pooling purpose we are using max pooling, right? So now I am going to add a max pooling of 2D. So whatever, so here, so the max pooling of 2D, this thing. So here, okay, then again I'm going to again use the convolution 2D with ReLU. So here you can see convolution 2D with ReLU, one more layer, and after that I'm going to apply the again max pooling 2D here, something like this. So after doing these two, then I'm going to flatten my complete input. So here you can see this is flatten, right? So here you can see, right? I hope everyone able to see here this flatten, which means just to make a 2D into 1D. So flatten my 2D and adding fully connected layer, and then output layer. So here I'm doing the same. So first flatten my output, and then adding dense layer. Dense is a fully connected layer basically, and this is the output layer. In output layer we are having 6 classes, and I am using activation function softmax. So here you can see that, so we are using softmax in our output layer, and this is our fully connected layer called dense layer, and with ReLU function on the dense layer. So this is the basically a network or complete architecture of neural network architecture, which are going to train with our data set. Okay, now I'm going to use the optimizer for compiling. I'm going to use the optimizer as Adam, and loss function we are going to use a sparse categorical cross entropy loss function, and our metrics is a accuracy. So this cross categorical cross entropy, which is nothing but we are having a classes like 0 1 2 3 4 5, right? So here uh, with each class 0 1 2 3 4 5, right? So this categorical entropy loss, it's trying to find whether if it is predicted if it is actually it is 1 but it is predicted 0, then it is going to compute the loss here. So for that we are doing this categorical cross entropy loss, and optimizer is equal to Adam. Okay, so this is with respect to compiling. Okay, now I'm running the script. Okay, so our model is ready. So if you want to visualize also, if you want to plot the model also, we can do. There is a model dot plot. I will show you. I think I will plot the model also. That is useful for everyone to understand. Okay. Save, wait, or transform each. Yeah, wait a second. I think we need to down. I will show you. So whatever, if you find anything, if you want to find, I mean, if you need anything, you can take the document reference and see in the document reference. Almost everything is, yeah. Summary is okay, but I don't want the summary. So I want a plot. So we can get the plot actually. Yeah, I will show you now only how to get the plot. Okay. Yeah, add box and yeah, in yeah, I think we need this. Okay, TF is, yeah, okay. Plot the model with model, and yeah, here you can see. So this is the means I just want to show everything. So that's what I trying to make. Yeah, here you can see. So this is the first our convolution 2D, and then maxful 2D, maxful 2D, then again convolution 2D, again maxful 2D, then flatten, then dense layer, and final dense layer. So this is the basically this is the network. So here in this, I think so. This is how we saw in a slide. So this is how in real time on coding. Clear. So I hope this is helpful for you. Yeah. So actually, I just want to visualize. So that is not required normally. Yeah. So now what I'm doing, so I did compilation also. Now I'm trying to do the training here. So this part is called as training my model with what I'm trying to do is now I'm training my model with my training data set. So this is called as training, and here we are a model dot fit and with training images and train labels, which means we are giving training images at the same time we are giving labels also for each image. And I'm using a split of validation split of 0.2. So yeah, here you can see. Oh, I think we are not run this code. Yeah. Okay, so now it is training. The training is started. So here you can see epoch. So I'm using epoch of 20, and here in each epoch you can see this is the loss with respect to this epoch, and this is the accuracy 0.557, and validation loss and validation accuracy. And you can see that loss is decreasing, accuracy is increasing. So this is what we are looking for. Means every time whenever each epoch, the model is trying to update the weights and in the such a way that it trying to improve the results basically. So this is called as BAP propagation, how BAP propagation helps to train the model. Okay. Yeah, it takes some time, but we will see. Basically, this is a very simple and very simplest convolution neural network. Means a very simple architecture. Basically, we can use complex architectures also, but as of now, I want to everyone to understanding how the things are work instead of making complex. I just make sure everyone can understand the convolution neural network. Okay, so it is taking running. So epoch 16 by 20 and 17 by 20, so 18 by 20, 19 by 20. So yeah, but our target is not on our training accuracy. Our target must be on validation accuracy. So please note that point. Every time we need to consider validation accuracy, not the training accuracy. So here you can see, I will show you. Yeah, so this is the basically this is the plot. So this plot will explain. So this is the epochs, like at 0th epochs the accuracy is somewhere 0 like 0.55. If you you can see the validation accuracy, means with respect to accuracy how the graphs are, and with respect to loss how the graphs are. So if you found this value is very high, means if you found there is a huge difference may come in, means it is very say we are seeing very huge difference, then we are facing the problem of overfitting basically. So now after our validation also done, so now let's look into the validation, how our model works on a tested data set and what is the accuracy we are getting. So here you can see on our test data set, like our test images and test labels. And here we know the test images, what is the image, and we know the label also in this test image, because here you can see this is the test, uh, and here this is the classes. In each classes we have the images. So we know the image as well as the true label. So using those values we are getting, means we are doing the evaluation on the neural network architecture, simplest neural network architecture. So we are getting the results something like accuracy of 0.79 13, accuracy and loss of 1.0948. So this is with respect to very simple architecture with simple convolution neural networks, how it will like, right? So now let's see the prediction, uh, how it is predicting. Yeah, so here you can see. So I'm giving some kind of means I'm giving one a test image, and so here this is the value. So the image is something like this. So image and image number, I think this is number is something different. I think this number. Okay. So but if you see the image, so the prediction is seems to be correct, but we are getting that 76 now. In 76 it seems to be correct, but we also get wrong predictions also. We need to take care of that, but as of now, so whatever our model or simple convolution neural network predicts, so as follows. Here you can see this image, the prediction is forest, and it seems to be forest only. Okay, now now let's look into the error analysis, means how much percentage it is going to misleading, means what it trying to say in wrong predictions, means how much percentage it is predicted as a wrong. So here it is actually mountain, it is predicted as a building. It is something different, it is predicted as a greaser. And here it is building, but it is mountain. It is actually it is mountain, it is sea. So something like that. Because we are getting only 79% accuracy, not 100% accuracy. That's what we are facing this mispredictions basically. So here basically for overall evaluation, we have a concept called confusion metrics. So confusion metrics is the way to analyze the predictions. So here you can see out of like confusion matrix will explain, it's like a grid which explains how many times, means for each class. Basically here you can see this is mountain and this is mountain. This many times it is saying mountain, but here 7 times basically so the true value is mountain, but it is saying as a street. But here you can see the huge number, like it is mountain, but still this many times it is saying as a glacier. And here 26 times as a building, 65 times as a sea, 7 times as a forest. So for street also 18 times as a forest, 3 times as a sea, and 89 times as a building. So something like that. But for street and street, this many times. Okay. So this is something like this. So this confusion matrix explains completely about what is the distribution and how the distribution means how the prediction it is with respect to each class and like that. Okay. So basically we are troubling with mainly with these two, mountain and greaser. So that is a point based on my analysis. So till now we discussed with a very simple neural network and very simple neural network. Let's see. Let try the same thing with VGG. So I told you right VGG about VGG. So this is VGG, right? So let's see the same thing with VGG, and we can get idea about it. Like okay, uh, yeah. So in VGG, so we so here I am first. So VGG is basically this Keras is a part of TensorFlow. So in Keras, we have a Keras applications. Keras applications. In Keras applications, uh, 1 second. I'm getting some call. Yeah, yeah. So yeah, sorry for small break. Yeah, so till now we try the simple convolution neural network and we saw the solution also. Now I'm going to introduce the new thing, so that is called as already pre-trained model. Means already we are going to apply the successful convolution. Means instead of deciding our own convolution architecture, let's see with the same thing with already existing successful CNN architecture, how the results are. So we are getting the results around 79% accuracy, right? Let's see with respect to VGG16 how much result we can get. Okay. For that we need to first import the VGG. So VGG basically in Keras or in TensorFlow, VGG available in Keras applications. So here you can see what are the available models we have in successful VGG is means these are the earlier ones. These are the updated ones. So tomorrow we will go on to discuss about the efficient net. So so today we will see this VGG and VGG 16. So this is the like here this is VGG 16. So basically this is the function. So if you want to use a VGG, so this is the way to use the VGG. So for that, so for our purpose, I'm just from Keras application VGG 16. I'm importing VGG 16. Along with that, I'm using pre-processing, one pre-processing function image in Keras, and I'm using pre-processing input for VGG. Okay, so I'm importing those information here. So here I'm running that script. So here it is imported. So now let's look into the features based on our training dataset as well as test dataset. Now first I'm trying to see the features, training images features as well as test images features using this model, use VGG16 model. Okay, so here you can see that. exactly what I'm trying to say. So here what I'm trying to do is, first I'm trying to predict the training features using my VGG16, using my training images, and test features using my test images, and taking the feature shape and all, and I'm using a decomposition function, and in decomposition I'm using PVA, like it is a dimension reduction function basically. I'm using that, and here you can see the visualization, how the patterns looks like. So whatever I told you now, like initially, so the distribution is something like this. So here you can see the uh, group of green, group of blue, group of red, group of orange, group of something chocolate color, brown. Okay, so basically this is how the features are extracted. So this is the how a way to visualize the features. Okay, now let's train our image, our data set with VGG16 pre-processing. So let's see the output also. So basically it looks very high speed, because they everything is very pre-trained. So here you can see the plotting also, and here you can see the evaluation. So previously we got 79% accuracy, right? Using our um, simplest architecture, we are getting around 79.13 on our test data set. Now with using VGG16, so we are getting somewhere around 87.43. So this is very huge difference. Yeah, 79 and 87 both are very huge numbers. So basically this is a very this is the difference, and we have an advantage over of using transfer learning. Basically this concept is called as transfer learning. So tomorrow we are going to initial hour we are going to discuss more about the transfer learning. Then we will discuss about the one advanced neural network architecture called efficient net. Then we will see one more project, how to solve, means how to solve that project using efficient net. Okay, but as of now, so this is called as transfer learning, but we are using the existing architecture, mm, same existing architecture in our problem, in our training data set, in our problem use case. Okay, now let's see with the seed neural network, so how many estimators and stuff like that. Okay, yeah, so yeah, so here we are seeding the neural networks, number of estimators, how many estimators are required and all. So let's see with that perspective also. So here you can see, so this is a way basically, how many means estimator, we are giving some random count of estimator, and out of that estimator how many estimators are there, and how to find, I mean how which is the best estimator we can get. Basically this is the way to get a good score. Basically I'm trying to get a final good model on my data. So I'm trying to take uh, all estimators and trying to predict using all estimator and consolidated output, and give that value as a final prediction score. Basically we are making some more complication, means complex to get a good results. So here you can see, using this complex we are getting somewhere around 0.88% accuracy. So with simple VGG we are getting 87, right? But with complex model we are getting around 88.63 with standalone CNNs only, with only CNNs. But we are trying multiple combinations and try to see with multiple combinations. But now let's see fine tuning way of VGG ImageNet. Now let's try with fine tuning. Fine tuning is something we are not using completely VGG. We are taking the VGG features, but again we are building our own convolution neural network on top of VGG. So that is called as fine tuning. So here we are take till here we are taking the VGG. Now from there again we are taking one more convolution, one more max pooling, flatten, dense, and final output layer. So this is called as fine tuning. We can say it is a fine tuning. So let's see with respect to fine tuning. In summary, you can get that information. So in starting, the starting layers are with respect to VGG, but from here, the layers are with respect to our own customized layers. Here you can see that layers. Okay. Now I'm going to train with this new model. What is the score I'm going to get? So my target is to get the maximum possible score, means to get a very good model. Meanwhile, during the training time, if anyone have any question in during training, or if anyone find any difficulty in this codes, please let me know. I will try to answer the questions. Meanwhile, I think this took 2-3 minutes to complete. At least 2-3 minutes it requires to complete. So we can have a question and answer session there. And I want to answer from, means is it clear, or still anyone I mean still you are finding any difficulties in coding? Means it is something requires some practice, but as of now, just take a note of it as a flow. Take a note of if anyone is not having idea about the coding and Python and everything, just take a high level note. So once you are familiar with Python, then everything you can understanding very easily.
Sir, can you share these slides?
Yeah, sure. I will share everything. Like I will share the code as well as the slides, and I'm taking everything as a public source only, not a very specific project and all. So everything is for learning purpose. So I will share.
Okay, sir. It's help to work the programs, sir. So only
Yeah,
I'm
sure.
asking.
Sure, definitely. So every day means every time we usually do that thing. So yeah. Yeah. Mahendra, please ask your question.
Thank you, sir.
Yeah, thank
So
you.
it's not a question, sir. So it's all about like so as I'm finance background. So till yesterday having like a much motivation like knowing Pythons, and now looking at the more this coding, so getting some confusion and bit
No, no,
complicated things now I can
no.
see.
Yeah,
So,
complication is basically this is advanced, means this is a complete one program, one project code. Means
uh,
see, you are direct sitting a first class student in a 10th class, so something like that.
yeah, yeah.
Yeah,
So
if you start from first class, it is very easy for you. Means
correct.
which means if you I think there is no fancy things are there, I feel. Means because I'm in a 10th class student, so that's what I feel.
Correct.
There is no fancy students,
Yeah.
but yeah.
So this CNN, this modeling, is it can help me to like pull the data from my PDF into the Excel, or the only pandas will help me to that
PDF data into.
Excel, like the dedicated. So the pandas,
No,
those going to
PDF is
help me.
something is different. Yeah, PDF is something different. The format of PDF is something different, and you are asking something in different. Like we can say basically, if you have your data in text format,
Uh-huh.
we can read the text file, and
Uh-huh.
we can make a panda data frame, and
Okay.
from the data frame we can export some, we can make the structured way, and we can whatever we are, if you are giving the text file with very means very huge data, or huge huge amount of data like that. So we are reading complete data in from your text to this data frames. In data frames we will write some script to, based on your requirements. What is the requirement you have? Based on that requirement we can write the script, and after writing the script we can export the results again as a Excel or something, CSV or Excel or JSON. Some output formats also there. So
Okay.
from output format you can get to know what is the output we are getting. Like for example, see, for example, in text file I am giving what are the, like for example, if in test file, so let us take an example of this only, like we are participants, right? So I'm going to give my like I have a text file with information about each participant, and whether what is the qualification of the participant, where is from that what is the location of the participants and all. So if I have a complete data in the text format, so then I read the data and make the data into the data frames, from the text
Mhm.
format to data frames. In the data frames, I will try to make some useful information. Means instead of complete data, I will make,
Mhm.
hey, only in this complete participants, PhD participants are this many participants are there. MTech participants are this many. BTech participants are this many. So instead of checking, like we can make this kind of analysis we can do.
Analysis.
Yes.
And the same can be like a scanned image copy, so we can portrait like a pull the data, like how the optical character reader that works. So
Actually,
this CNN
that is
works,
so basically you are asking something like you are having something on your image. Some, for
right?
example, you have an image, and
Yes,
in that image you have some text
yes,
on your image. So you
correct,
want output. That output will extract the image. I mean, text from your image, right?
correct, exactly. From a particular,
So
like it's been a template, something like a dedicated sections of
yeah,
the top left,
yeah, yeah,
top right,
yeah,
bottom, middle,
yeah.
back.
Wherever it is, if it in the image, we can extract it.
Okay. So
Yeah,
this framework will
basically,
help me, so I can
yeah,
like work
not
around
this
with
frame,
this.
not this framework. So I mean, you are asked means you are looking for a kind of solution. I will show you with Amazon. I mean, Amazon is showing providing so many solutions. So maybe this solution means whatever you are asking, uh, you no need to worry about the technical perspective. You just use
Correct.
the service. I mean,
Okay.
it is actually this is paid service. If you are,
Okay.
if you want your solution is very useful, means if you want the solution and you no need to put any efforts, you just give a input as a image and you just want the output. So basically, there is a one service, one neural network, one complex and advanced neural network is there.
Okay.
Architecture is there that is within Amazon.
Sure, I
So
will
this is,
explore, sir, then.
yeah, yeah, yeah. Then Amazon Recognizer. So Amazon Recognizer is a automate your image or video analysis with so here you can see that. So it will try to, like, if you send one image to the model, then the model will extract the image, means extract the information present on the image as a text, as an
Text.
output.
That's what looking. So I will
Yeah,
explore this then.
yeah. Then you can take a note of it, like Amazon
Sure.
Recognizer. But it is actually, this is a paid
No
thing. So
problem. So there
yeah, yeah,
won't be any issue. So yeah.
yeah,
Thanks, sir.
yeah. Thank you.
Thank
Sir, what is the purpose of AWS?
AWS is a cloud platform. Instead of running in your local PC, this AWS provide a virtual desktop where we can do our whatever we want, like host the application or run some task or something like that, or
Okay, sir.
store the data, or so many features are there. It's something like that. Like,
Okay, sir. Sir, what
yeah,
is the exact part to get into Amazon?
what is the exact path?
To get into Amazon.
Uh, uh, I mean, that is not easy to say exact path, but whatever the role you want, search on Amazon Jobs portal. If you find the role best fit for your experience and your knowledge, and you can also fulfill their requirements, then try to apply for the job. That is a way, like, to enter into Amazon.
Like, sir, what prior knowledge is required?
Yeah, there in the portal itself they are mentioned, right? Everything they mention in the portal. What is the job skills? What are the skills required? What is an so everything is present, means provided there only. Like, what is the what is the education qualification required? What is the skills required? And what is the experience required? And everything is provided in a web. portal. If you see one portal or one Amazon web page or one job uh, page post, then you can understanding everything.
Okay, sir.
Yeah, thank you. So here you can see with our fine-tuned VGG, so we are getting the accuracy of 0.9 0.9096666, something like that. So we finally able to successfully we are able to get the 90% accuracy algorithm with using VGG fine tune. So we can improve also with advanced convolution neural network architecture. But as of now, this is the means we can improve maximum 0.91 to max. But 0.90 is a very good number, I can say. 91, it is near to 91. So this is all about how we are going to classify how we are going to use a convolution neural network in image classification. Okay, I hope everyone is clear. And Kiran, can you please ask your question? Like Kiran KS raised a hand.
Yes, sir. Sir, am I audible?
Yes.
Yes, sir. Sir, can you suggest any study material like for the beginners, which will be very helpful while understanding the things?
Study material which on which topic? And Python programming,
Like
ML.
particular, Python programs. So, like for beginners, if you want is interested in looking into the career, so what kind of source it will be very helpful, sir? Like,
Yeah, basically take any one source from means NIT Varangal conducting one short-term programs specific with Python programming, means from beginning level, means professors are explaining in a very way to like beginning level to advanced level. So that is a one way, and you have a multiple resources are there. Just see on uh, browser and means to see on internet what are the available courses and what is the review, what is the count of review, something like that. But I suggest I mean NIT Varangal already providing some uh, Python programming, Python short-term programs and all. So that is means, so the advantage is we can get an interactive way, and they are also helpful us uh, uh, to how the Python is going to use in industry.
thank you very much, sir.
Yeah, thank you. Any questions and doubts? I mm, okay.
Hello, excuse
Yeah,
good
yes,
evening, sir.
yes, please.
Sir, so how we decide how many convolutional metrics we
Uh,
will be doing for a
yeah,
given data set?
yeah, that is a very interesting question. So that concept is called as hyperparameter tuning, basically.
Oh,
I'm
okay, yeah, hyperparameter
okay, tuning.
tuning. Okay.
So
Sir,
the
can you
whatever
tell
you
me
are
because I
asking,
forget that one. So.
yeah, hyperparameters tuning is something uh, we are doing the experiment with the parameters like number of layers, number of neurons present in each layer. So it is like a complete experiment. Not there is no a simple rule to say, hey, this many this is a way to find best hyperparameter tuning. But we have some libraries are there, like we have a libraries with auto tuner in neural network. We have a auto keras tuner. So auto keras tuner is helpful to find the hyperparameters. I think auto tuner, not keras
Okay,
tuner.
auto
Keras
keras,
tuner, yeah, keras tuner.
keras
You uh, yeah, keras tuner is helpful to find the hyperparameter. Yeah, here it is easy to use and scalable hyperparameter optimization framework that solves the pain point of hyperparameter search. You got it.
Okay, sir.
So by using keras tuner, the keras tuner is help figure out the best parameters instead of we are doing manually, like
Manually, yes. Okay.
yeah, this keras tuner is things will works and find the
And sir, you told us there will be an activation function, right? When we
Yeah, that is also hyperparameter tuning only, like
Correct. So
ReLU.
Relu, is that the only activation
No, no,
function
no.
available? Or?
There are multiple activations are there. Activation functions are there. Here you can see.
Okay. So how
ReLU,
we
TANH.
decide, sir, which
Yeah,
function to be
here
used?
that is also hyperparameter tuning. We are not a straightforward answer
Oh,
to say.
okay.
Layer activations, here you can say
Okay. So
ReLU,
there are so many
ReLU
functions.
functions, sigmoid, softmax, so TANH, SALU, ALU, and so you can explore it and you can get understanding each function
Okay, it is
and
in
purpose.
Keras library. Okay, sir.
Yeah. 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 Thank you, everyone. I think we crossed 7 minutes more, and I hope everyone is clear with our session. And thanks for your kind cooperation and good. Yeah. So I'm just giving a session, hand over the session to the organizers. Yeah.
Thank you, sir, for such an informational and knowledgeable session. Your way of teaching, along with clearing doubts of the participants, has surely provided a strong conceptual clarity. I
Yes.
also like to thank all the participants for joining today. The information about tomorrow's sessions will be shortly handed over. Thank you. You may
Yeah.
all
Thank you.
leave.
Yeah. Thank you. Thank you all.